Hello and welcome to Mellow Labs. On today's episode, we're building a speed sensor so that I can finally find out how fast I'm running. This video was brought to you by Patreon. You can probably tell I'm not the healthiest individual and apparently I'm putting on some weight. So I need to do exercise, which means I need to make exercise more fun because God is it boring. One way of making it fun is by adding some sort of competition aspect to it. And yes, I could focus on distance as a good marker, but I'm only running back and forth, so I'd rather focus on speed. So, with the explanation out the way, let's go make it. Now, there are many ways of measuring speed. The first one you'll probably be thinking of is the radar gun, which does its job very well, except they are very expensive. The cheapest one I've seen was about £80, which is a little too expensive for me. And then we have GPS, which is great when you're in the middle of an open road. Terrible if you're running back and forth in your kitchen. And then we also have, you can also grab a video of yourself running in front of a ruler, then bring it into a video editing software, cut out the bits where you're going from one end of the ruler to the other, see how long that is. In my case, that is 11 milliseconds. You can then go to a calculator soup and you can put in your values. So I went over 1 meter and it took me 0.11 seconds to get there. You can then click calculate and that will tell you that you did it in 20 miles per hour. But that sounds long and boring, so let's not do that. We're gonna have to figure out our own way. Luckily, calculating speed is as easy as speed equals distance over time. What does that mean? So to use this mathematical equation, all we need is the exact amount of time it takes us to go a specific distance. So, for example, if I have button A and over a meter of a distance, I have button B, and obviously we need some microcontroller in the middle to sort of keep track of everything. So all we have to do then is hit button A, run the meter, and then hit button B. And then that would give us the time and the distance, because we already know what the distance is, which would give us the speed. Unless I got all of this wrong and I'm just making myself look like a complete doofus right now. So by now, you're probably asking yourself, how are you going to execute this? Well, simple. First, microcontroller and a display to tell us how fast we're going. Now obviously we don't want to use buttons because pressing them adds extra time. So instead, I'll be using lasers and photoresistors. So then what we have to do is run through this, and the first one will tell it, hey, there was no light for a second, which will tell the microcontroller to start counting. And then we break the other beam, and then it tells the microcontroller, hey, it took me this long to travel this distance, which will then output speed. And it should be as easy as that. Will it work? I don't know. I haven't made it yet. So I guess let's go make it. This is my little DIY laser pointer. Yes, I realize I can buy these for like pence. I didn't want to wait for delivery. I already had laser diodes, I had batteries, I had switches. I might as well make my own. I also printed out this little holder for them just to sort of keep them steady whilst I'm aligning them. It's not perfect, but it works. The photoresistor part is even simpler. It's just a photoresistor and I've made my life easy by putting a connector, and it's literally just connected to the connector. I put some heat shrink tubing on this. Eliminating stray light is kind of the hardest part, so I had to think about that when I was designing the enclosure. For that reason, the enclosure is in 2 parts. So the board goes in here, like so, which gives us access to the port here, and not a lot of light gets in through that port, which is good.
This is mostly here to screw the lid on, and I've got this tube on here to prevent any more stray light from coming in. So the photoresistor board gets screwed in there, this gets screwed on here as well, and then I just plug in the microcontroller and we're off to the races. Now obviously for my experiment I need 2 of these, and because I was raised on Blue Peter, here's 2 I made earlier. And here's the over-complicated looking rat's nest that has the microcontroller, the screen, and the 2 connectors for the photoresistors. So let's go test this out.
Right, I've got everything set up. I've got my little DIY laser pointers and the little light sinkholes. So the way this works is I've got this laser going into this photoresistor, which I then have connected to the analog in pins of the Raspberry Pi Pico, which lets me attribute a high number to a 0 and a low number to a 1. So that's how I know that something has crossed the stream, and the same with the other one. And the way the code works is when I cross this stream, it takes a timestamp, and then it takes another one when I cross this stream, and then it takes those 2, finds out what the difference is between them, and then using a set distance value, which is set to a meter. I know this isn't a meter, but for the demonstration it works. It's set to a meter, and then it tells me how fast I would be going if I traveled that distance in that time. Therefore, if I go like this, I can tell you that that was 20 kilometers per hour. How fast can I go? 144 kilometers an hour. So, now that this works in practice, I can lay this out and time myself running. Okay, after over an hour of setting it up and troubleshooting, it is ready. It will now tell me the speed from here to here. So, let's test it out. There's one small bug. If I cross this beam, going this way to like ramp up for the run, I have to like reset it with the broom. Minor inconvenience. 13.333333. That's good. Let's go again. I'm speed. 15. Hell yeah. I can go faster. 240. What? There are some bugs. Me running and shaking everything does also like misalign the lasers. 16. Hell yeah. I'm getting good at this. 18. Ow. Well, I got 18. I'm pretty sure I could probably run at 20. 15. Damn it. 13. That's slower. 18. Damn it.
Sonny's probably wondering what the fuck you're doing. He's coming up.
Hiya.
Thomas, what's going on? The ceiling's coming down.
So, that will conclude this video. With my neighbor's complaint out the way, it's time to conclude this video. Does it work? Yes. Is it accurate? I don't know, because I'm not willing to cross-reference it. I'm happy the way it is. Thanks for checking out this video. Don't forget to like, comment, subscribe, and if you have some spare change, I have a Patreon. I would greatly appreciate it. You get exclusive content, behind the scenes, and early access. I think my early access is like 3 weeks ahead of my YouTube schedule, so check it out. Till next time, goodbye. Don't forget to like, comment, subscribe. If you'd like... Fuck. Shut up.